Hi and welcome. In this video we are going to solve the problem. This given two arrays of unordered numbers, check whether both arrays have same set of numbers or not. For example, if I have A and the numbers are 3, 6, 5 and 9, and if I have B and the numbers are 5, 3, 8 and 9. Okay, so they are both unordered. So do they have same set of numbers? So 3 is present here also. Okay, 6 is present, no, 6 is not present. 5 is present, yes. 9 is present, yes. That means 6 is not present. That means in A 6 is present and in B 6 is not present, so they do not have same set of numbers. Fine. If it was 6, then yes, they do have same set of numbers. So given two arrays, we need to find out whether both the arrays have same set of numbers or not. So what is the most basic approach? So the most basic approach is using the nested loops. What we can do, for each number in A, we can just traverse B and find out if this number is present or not. So the complexity is nearly n square. Now, but the problem with this approach is, what about duplicates? So it does not take care of duplicates. For example, if we have 3, 6, 5, 9, 3, 8, and here also we have something like 6, 3, 5, 8, 3, 7. Fine. So if 3 is here, so it takes, yes, 3 is here. Fine. Now we have 6, we have 5, 6 is also present, 5 is also present, let it be 9. Now 3 comes, so when 3 comes again, so but just by checking this, it says yes, 3 is here. But what if 3 was not present, some other value was present? What if 8 was present? Now here we have two 3's, but here we have just one 3. But this algorithm of n square will tell yes that both the 3's are present in B array also. Okay, so therefore this fails when we have duplicate elements. Fine. What else we can do? We can sort the array. Okay, we have 3, 3, 5, 6, 8, 9 and 3, 3, 5, 6, let's say 8, 9. Okay, we have two 3's. So now we can compare each of them. Complexity is n log n. Fine. So can we do any better? We can use here hashing. Fine. So what is the hashing is, space complexity will increase because we are using an extra hash table, but the time complexity will reduce to order of n. Now how do we do this with the help of hashing is, just given an array A, let's just take same example 3, 6, 5, 9, 3, 8, and given an array B, what we will do is we will create a hash table. Okay, now in this hash table we will be storing all these values as keys and their frequencies as nothing but values. Fine. So all these elements will be keys. So 3, 6, 5, 9, 8. Okay, now what are the frequencies? 3 is coming 2 times, 6 is coming 1, 5 is coming 1, 9 is coming 1 and 8 is coming 1. Okay, after taking the just array A as input, B as input, we are creating a hash table and we are choosing the array A elements, forming the table. Now we will traverse the array B. Now if 6 is coming as B, we will just decrement it, make it 0. 3 is coming, decrement it, make it 1. Then 5, make it 0. Then 6, 8, make it 0. Then 3, make it 0. Now 9, make it 0. So all the elements, now there are no elements present and all of them are currently zeros, so nothing but all the sides, both A and B, have same number of values. As simple as that. How we will know that they do not have same number of values? For example, instead of 5 we have here 7. Now when we go to this 7, okay, we have nothing to increment. If we decrement from 0 to -1, we will decrement from 0 to -1. So we'll just check for this condition. Okay, if we are decrementing less than 0, if the current value is 0 and we are decrementing it, that means B has some values which are not present in A. And if after the B is over and all these values are not 0, any one of them is remaining, for example 5 is remaining, that means B does not have 5. So we will know that both of them have different set of numbers. So in the case only that all of them are zeros, in that case we can say that yes, A and B have same set of numbers, else we cannot say that they have same set of numbers. Fine. So how will the algorithm in the pseudocode look like? Let's see that. So first is we take all the inputs. Second, after we take all the inputs, we will just create a hash table, okay, or a hash map using the A array. Fine. So here the elements will become keys and their frequency will become values. Then we will traverse our B array and there are 3 conditions to check, actually just 2 conditions to check. If element is not present, then return false. if element is present but current element has a frequency of 0, that means we are decrementing it to -1, then return false. Okay, else we are simply going to decrement it, else we are simply going to do minus minus, just simple decrementation. Okay, just simple decrement. Fine. Now if these two conditions are not true throughout the B array, okay, we will simply print yes, the arrays are same. If any one of these conditions become true, we will break and print no, the arrays are not same. Fine. So let's see the implementation of it. It is very direct, straightforward implementation. So let's see the implementation now. So here is nothing but our test case input, then n is taken as input, arrays are declared, arrays are taken as input, normal stuff. Then a hash map is created right here. Okay, this is the inbuilt hash map. So now what we are doing, we have to traverse the array A and we have to fill our hash map. The elements of array A will become the keys of the hash map and their frequency will become the value. So what we are doing, using the get function, we are getting the value that is currently present at array I. Currently everything is null. So if first time an element is inserted, we have to simply put the value as 1 if the first time element is inserted. So this is nothing but for the first time. If it is not the first time, then we will simply get the value that is currently present and add 1 into it. Get the value that is currently present using the get function and add the value into it. Simple. Fine. So put function is used to put the values and get function is used to get the values. Okay. Put has two arguments, that is nothing but the key and the value, and get has just a one argument, that is nothing but key. So this is how our hash map will be filled. Now a boolean flag variable is true. Now if the flag becomes false, that means the array elements have different set of numbers, and if the flag remains true, that means both the arrays have same set of numbers. Okay, so if there is an element in array 2 but not in array 1, in that case what we are going to do, we are going to make flag equals to false and break. But if an element of array 2 appears more times than it appears in array 1, in that case also we are going to make flag equal to false, else we are simply going to decrement the current value present inside that key. Okay, so this is the key and this is the current value and we are decrementing it by -1. Fine. How we are going to check it? Using the contains key function. If the key is present, it returns true. If the key is not present, it returns false. So this will return me a false if the key is not present. Not will convert it to true and the flag will become false. Okay. Else this means that the current frequency is 0 but a B array 2 elements occurs, so B array elements occurs. So in that case we will make it -1. So that means we have to make it flag equals to false as explained. So it will break and this is how it is printed. So if we just run it for few test cases, these are some of the test cases. Okay, and this is nothing but a simple implementation using a hash map. Fine. Thank you.